we will talk about micromeritics. What's really micromeritics is the science and technology of fine powder. Pre-formulation tests done on powder or granules in order to put them in a solid dosage form in suspension. So what is the objective of our lab is to determine the powder densities of zinc oxide, the bulk, tabbed and the granular, and to determine the particle size distribution for sodium chloride powder using sieving technique. There is assignment in that lab uncovering the DTP, and the same case in that assignment is the counseling for group 2. Please watch this video on YouTube explaining the practical part of this experiment. First of all, densities is universally defined weight per unit volume. يعني بس علينا نقسم الويت بالجرام على الفوليوم. لكن there is different types of densities of solid dosage form. This is different from liquid dosage form because liquid, the volume is the volume of the liquid, but the volume here it's subdivided into 3 volumes. The V bulk, which is the total volume of the solid, and intra voids, الvoids يعني الشقوق الفجوات the cracks الداخلية الموجودة جوا البارتيكلز, and the inter voids الفراغات الموجودة بين البارتيكلز. So the total volume it's the volume of the solid Vt plus the volume of the intravoidage and the volume of intervoidage. هلا إذا بدي أطلع بس على الفوليوم of the solid Vt plus the intra volume of the voidage inside, I will get smaller volume than V bulk, which is the Vg, granular volume, and the smallest volume, which is the true volume of the solid without any voidage or cracks inside or between. So there are 3 types of densities we can calculate for the same weight of the sample. If we have 10 grams of zinc oxide, let us say, we will have different types or different values for the volumes. VB will be the largest, then VG, then the smallest, and the constant volume, which is the volume of the solid VT. So we can get different types of densities. V, if we measure V bulk, and if we divide the weight on V bulk, we'll get true we'll get bulk density, which is the smallest value because V bulk is the largest. And if we divide the same weight of the powder on the true volume, we'll get the largest value of the density, which is the largest value because the Vt is the smallest and constant, and that will be saved in references. Okay, so our objective today is to measure the true density and how we can measure that true density using helium pycnometer. Helium pycnometer is a device usually using helium, in which we can use that helium can displace the inter and intravoidage. So by adding our sample in the sample compartment and open the gas chamber, the gas can enter and displace the inter and intravoidage, and the pressure is measured. Then this device, helium pycnometer, will convert the pressure into the volume. At the same time, the same amount or different amount of helium will enter into empty gas chamber, and the pressure is measured and converted into volume according to ideal gas law, PV equal nRT. And this experiment is done at room temperature, constant temperature. So we know the number of moles, and we know the temperature, and the pressure is measured, so the volume is measured. By subtracting the volume of empty chamber minus the volume of the gas in the sample chamber, we can get the true volume. This is also, I will add, you can watch that video on YouTube. Just try it on the YouTube, determination of true density using helium pycnometer, and it is done in our university. Okay, watch that video. Practically, we can measure the true density by helium pycnometer, and we can get it from the references. To measure the bulk density, we can use really a cylinder. Just putting our amount in that cylinder and measure the volume of that sample. It will be slanted, مائلة. So we'll take the upper limit of the volume and the lower limit and take the average. And also tap density is determined by tapping. We can tap it for usually several times to get constant value. We can uprise the same cylinder containing the powder. We measure the bulk density 1 inch from the bench and tap it 60 times during 2 minutes. That means if you open your stopwatch and tap it every 2 seconds 60 times during 2 minutes, and then you will measure the volume. Of course it will be less than the bulk volume, because during tapping there is a rearrangement of the voidage. The intervoids will be less than that available in the bulk volume, but it will be there. So if you want to compare the tapped volume compared by bulk volume, it will contain the same 3 values but in a lesser amount. That means tapped volume contains the true volume of the solid as in the bulk volume, and the intravoidage as in the bulk volume, and intervoidage as in the bulk volume, but the intervoidage volume in the tapped will be less. To measure really the granular density, you have to watch the video that I put it here in this slides, but it is easy because we are using a technique which is called liquid displacement. We will add water to the zinc oxide because water cannot dissolve zinc oxide and can displace the intervoidage and with the zinc oxide. يعني لو ضفت مية على الزنك oxide المية بتبلل الزنك oxide، ما بتفو على السطح. يعني ما بقدر استخدم مثلا المية للسلفر لانه السلفر هو اللي بيطفو على سطح الماء. anyway بوزن وزنة معينة من الزنك oxide وراح استخدم dry cylinder here. All the cylinders we use in this experiment will be totally dry. So it's the concept is just weighing, and we will use the same cylinder in the 4 steps for determining a granular density. First of all, select a dry clean cylinder, weigh it, weigh 2 grams of zinc oxide and add it to the same cylinder and weigh it again. This will be weight 2. Then as we said, we will add water to displace the intervoidage. Water cannot enter into intravoidage because of high interfacial tension between the water and the air inside the cracks. So by adding water up to 20 ml, so we can water can displace the intervoidage and not intravoidage. Then using a glass rod stirring to ensure that all the intervoidage are displaced by water, then add extra water QS to 50 ml and weight that cylinder. This is the third step really. Then the fourth steps, you have to discard all the suspension of zinc oxide and water, clean the cylinder and dry it from outside, re-empty it, refill it again using water to the Thermark 50, weigh it again, and by subtracting these four weights you can get the the granular weight or granular volume of the powder, because W4 minus W1, it's the weight of the cylinder containing the water minus the weight of that cylinder. That means it's the weight of 50 ml water. It will be near because the density of water يعني إذا عندنا 50 ml يعني راح تكون هذا الرقم قريب من 50، not exactly 50 بس قريب. W3, it's the weight of the cylinder plus the powder plus the water minus the weight of the same cylinder and the powder. It will give me the weight of water inside between the powders and the complementary, or to complete to 50 ml. So the first subtraction W4 minus W1, it's give me the weight of 50 ml of water, near 50 because the density of water is 50, minus the weight of water between the particles and above up to the Thermark. So يعني زي كأني بطرح وزن مي من وزن المي. طيب just imagine that W4 minus W1 is the weight of water. Imagine that water will occupy four values of volumes or weights: the weight of the true powder, the weight of the voidage inside the powder, because WT and W intra will give me WG, and the volume of the voidage between the particles, and the weight of the water up to the Thermark. We call it complementary. So the first subtraction, W4 minus W1, will give me, this is imagination, the weight of the powder, the weight of the voidage inside, will be WG, and the weight of the voidage enter between, and the weight of water complementary to the Thermark. It will be subtracted from W3 minus W2. That will be the weight of water between the particles and complementary. That will give me WG. And because I'm talking about water and density of water is 1, so it will give me the WG. It's the same as VG. But if you are working with another liquid other than water, let us say benzene, the subtraction will give you directly WG. So by giving you the density of benzene, so you have to convert WG into VG. Here in our example, in our work, we just we will get directly the value of Vg. The second part of micromeritics is determination of particle size distribution. It's one part of micromeritic preformulation study just to know what is the particles available in our sample and what is the percentage of their distribution. يعني أنا لو بدي أدخل particles لصناعة دوائية في tablet capsule suspension, first of all I need to know what are the particle size of my sample, because really particle size will influence different things: the solution, bioavailability, during manufacturing. So we have to determine particle size and particle size distribution. There are different techniques usually used in determination of particle size and particle size distribution. Usually one of them is using sieving, as we will do it in our lab. But another technique which is really easy is to mount a little amount of the sample in a glass slide and mount it with water or oil and put it under the microscope and measure the diameter of the powders inside. Arrange them into size ranges from the least into the large. So starting from, if you find the smallest one 10 micrometers so in diameter, arrange, and the largest one is 100. Arrange them into size ranges 10 to 20, 20 to 30, 30 to 40, until you reach 90 to 100 micrometer, and count the number of particles under each size range. This really is tedious, and you can measure really only 2 dimensions. So sieving is easier and the best. So how we will do it? We arrange a number of sieves as a nest, زي شبكة, from the coarser at the top to the finer at the bottom, and we put under that the finest one. We put a tray to collect what get out of that smallest sieve. So we will have 5 sieves. Arrange them from the coarse to the fine, and we put around 2000 grams of sodium chloride at the top, and we shake it or oscillate it for 10 minutes and just weigh the powder that retained inside, because after shaking or vibration, certain amount of powder out of 2000 will be settled down on the sieve. That means the surface area of that sieve is above or equal the aperture size of that sieve. So we can this table, including the bulk density and tap density and granular density and true density from the video you have to watch, and also the particle size distribution of sodium chloride that will be given the data for you. Also this is the video, you have to watch it, about the true density. Also, this is the assignment you have to deliver about a patient named Samira. Her age is 32 years old. She's suffering from rheumatoid arthritis, and she's pregnant in the 3rd trimester, and آخر 3 أشهر. She is taking at the same time, because she's pregnant, paracetamol and Malox, and the physician prescribed no pain DS. DS and double strength, 1 tablet by 2. Using that information, write down what is the DTP, what is the justification, what is the recommendation, find out what is no pain active ingredient first, and write the reference, that you use it to identify the DTP. Also, group 2 will have counseling on the same case. سميرة اللي عمرها 32 سنة اللي بتعاني من روماتويد ارثرايتس وحامل بالثيرد تراي مستر بآخر 3 أشهر وكاتبها لها الدكتور نوبين DS. برضو تسجلوا فيديو short video 2 minutes about counseling على هاي الكيس. Thank you.